So in the last session, we discussed about operators, different kind of operators which are available in Java. So we have seen all the different types of operators with examples. So we understood in detail what are the different operators available in Java. So in this session, we are going to discuss about control statements. So control statements. What are control statements in Java? For example, so say for example, I have some 20 or 30 lines of code in my Java class, right? So all the time, I might not be interested to execute all the instructions, all the 30 lines of code. Sometimes I wanted to execute only a block of code. So based on some conditions and just skip the rest of the lines of code for execution. So I might be interested only to pick up some block of code and wanted to execute only that block of code on meeting some certain condition criteria, right? So only then I wanted to execute that block of code. So that type of control over the flow of execution is what we call it as control statements. So there are some statements with which we control the flow of execution of the program. Such statements are called as control statements. So they determine the sequence in which statements are executed. So usually the line of execution of a Java program starts from top to bottom, that we have seen in multiple programs. But using the control statement, we can determine the sequence in which statements are executed. So how do we do that is using three types of statements. So control statements are of three types. So conditional statements. So based on some condition, we execute a block of code. And so that's what we call as conditional statements. We do have different types of conditional statements. We'll see that. And in today's session, we are going to discuss about conditional statements. And we do have loop or iterative statements. So we use loop statements when we wanted to execute repetitive actions. So say, for example, I have some block of code and I wanted to execute that multiple times. So I have a block of code written, some, say, for example, some 5 lines of code I have written. And in the subsequent program, I wanted to have the same action to be performed. What we can do today? So we can repeat those 5 lines of code again, right? So instead of that, what we can do is, so we can actually use loop statements to execute, write the block of code once, but execute that block of code multiple times using loop statements. And we do have jumping statements also, which actually control the execution of the program. So this we are going to discuss in the next sessions. But today we'll focus on conditional statements. What are conditional statements? So conditional statements. So conditional statement, we execute a block of code only based on some criteria. So based on some condition. So if some condition, based on some condition, we are going to execute the block of code. Such statements are called as conditional statements. So do not get confused with control and conditional. Both seems to be the same, right? But if you see control statements is used to control the flow of execution. So complete flow of execution, you can control using control statements. And these are categorized into three types. So conditional, loop, and branching statements. Conditional statements. So using conditional statements, we can control the, we can execute the block of code only upon some specified condition. If some specified condition is met, only then we'll execute a block of code. These are the conditional statements. So we do have if condition, if else condition, if else if ladder, and also switch case. We are going to discuss these conditional statements one by one with examples. So we'll understand all these conditional statements one by one with examples. So what is if? Let's start with if condition. So what is the if condition? So if condition actually executes the block of code based on a specified condition. So so the syntax of it is if. So if itself is a keyword. If, so we write some condition. So this condition can evaluate to some expression, which actually should return like a boolean, or it can even return an int. So based on that, we write some statements. So we have some condition. So if statement verifies if this condition is true or not. So if it is true or false, so based on this value, so if it is true, it enters into this loop. We call this as loop. So in the braces, we can write multiple statements to execute. So this we call it as a block of code. So if this condition is met, only then execute these statements. Earlier, what we used to do, we were not writing this condition. We didn't have any condition. So directly we used to write the statements, and these statements used to execute line by line. All the statements used to execute line by line from top to bottom. Now we wanted to execute these statements, some block of code, only upon some condition is met. So, and how do we do that? Using the if condition. So this is the syntax of it. So you'll understand better when you see an example. So let's take an example. I'm gonna create new exam. Okay, let me close all this. I'm gonna create a new package for today and name it as day 4. Let me create a new class. I'll call this as if example. Or we'll just say if condition. Say for example, I have, so let's take an example of voting. So what is the eligibility for vote? The person age has to be 18 or above. So only then a person is eligible for vote. So we wanted to check that condition. So let's take this as an example and understand. So age equal to, say for example, 25. Now, if let's call this as person age. If person age equal to, if person age, right? If condition, we have to write the condition. So what's the condition? If person age is greater than or equal to 18. So observe the syntax. This is the syntax. If there is some condition. So this condition, if it is true, only then execute the statements within the enclosed braces following the if condition. So I can write multiple conditions here. I'm gonna write it as eligible for vote. If you remember, the same example we have seen using ternary operator in the last session. So now we are using the same example, like we are taking the same example and to understand the if condition. So if you see, percentage is one variable, so it has some value, and we are actually writing some condition on that using that variable. So if you see here, the condition is if the percentage is greater than or equal to 18. If the percentage is greater than or equal to 18, only then the person is eligible for vote. So this is the reason. So if this condition is met, only then I wanted to execute the statements here. So there could be multiple statements here. There could be another statement 1 like this. I can have multiple statements written here. All these statements are going to execute only if this condition is met. Or else what happens? It doesn't enter into this loop. We call this as loop. So whenever we enclose some block of code in these curly braces, this is what we call it as block of code. So it doesn't enter into this loop. So if this condition fails, then it actually executes the statements after the closing brace. So after the closing brace, do we have anything? No, right? So or what we can do is we'll just print, okay, out of if. Right now, let me execute this program. So if you see, it says eligible for vote because this condition has met. Percentage is equal to 25. So 25 greater than or equal to 18, yes, the condition is true. As this condition is true, it entered into the loop and executed all the statements below it. So say for example, I take percentage as 15. Now if you see, there is no, it didn't enter into this loop because it has verified this condition to be false. 15 greater than or equal to 18 has become false. This is a false condition. So it didn't enter into the control, the program control. It didn't enter into this loop. So it just came out of this loop, or it just skipped all this block of code and tried to execute the statements following that if condition. So it just prints this, right? So this is how we can use the if condition. Now, say for example, I wanted to print something called not eligible. I know if this condition is met, it is eligible for vote. But if this condition is not met, I wanted to print something called not non-eligible or not eligible for vote. So how do we do that? Let's see that. So using if-else condition, we can do that. So how can we understand if-else condition is? So the syntax of it is again the same. If condition, some block of code, and if that condition is not met, we can write an else condition. Else condition is false condition. So if this condition becomes false, so we are checking for some condition. If it is true, we are going to execute some statements, some sequence of statements. If that condition is not met, what should happen? So if that condition is not met, so I wanted to execute some other block of statements. So how do we do that is, we can write the else condition. We will just say else. If this condition is met, fine, go and execute this block of code. But if that condition is not met, so execute this block of code. I wanted to execute some other sequence of lines. So that I'm going to mention it here. So this is how, this is the syntax of if else condition. Yeah. And again, like if you have only, say for example, if you have only only single statement under if condition, then having this curly braces is optional. So you don't need to have this condition, this curly braces. If you know that you wanted to execute only one statement on successful condition is met, then you don't need to have the curly braces. But if you know only, if you wanted to execute only single statement after the condition is met, you don't need to have the curly braces. But if you wanted to execute multiple statements, you definitely need to put all the statements in the curly braces like this. So it's always a best practice to have curly braces for the if condition, even though you have a single statement. That's a best practice. Now let us go to if else condition. So I'm gonna create a new class. I'll call this as if else condition. I just copied this class. Let me open this. So we do have, let me remove this now. We do have a if condition now. Now, say for example, if this condition is not met, I wanted to execute another block of code saying not eligible for vote. So what we could do, so if this condition is not met, if it is met, then we know it just displays eligible for vote. But what if this condition is not met? So say for example, if I am gonna write it here, I know it will not enter into this loop, but definitely it will execute this, right? So say for example, if I am gonna write like this, not eligible for vote. If this condition is true, it actually displays eligible for vote. Fine. If this condition is not met, say for example, I say not eligible for vote. So what happens in this case is, let's execute and verify. This is fine. So not eligible for vote because the percentage is 15. So 15 greater than or equal to 18 is false. So it will not enter into the if loop and it just came out and not eligible for vote. This is fine. But now let's see this condition. Now the percentage is 25. So eligible for vote. So it has to print eligible for vote, right? So if you observe now, so you'll get two outputs, eligible for vote, not eligible for vote. So why are we getting these two statements? Because we are saying if this condition is not met, display this statement, go into this loop and execute all the statements, whatever are there in this loop. So this is the only statement in that loop. So it actually displays that, comes out of the loop, and also there is a statement without any condition. So this is the normal flow. So it just executed that statement as well. So even the percentage is 25, there is some ambiguity here. It is saying eligible for vote, not eligible for vote, right? So this has to be solved. So how we can solve this is, so if we have the if condition, so we wanted to execute some block of code. Else, we wanted to execute some other block of code. This should not be executed all the time. Only if this condition is not met, only then the else statements has to be executed. So this is how we can write the else statement. Now, if I execute the same program, I'll just get eligible for vote because percentage is 25. 25 is greater than or equal to 18. This is true. So it just enters into this loop. That's it. Eligible for vote. It just prints it and then it doesn't enter into the else loop. As the condition itself has become true, it already executed these statements which are below the if condition and it doesn't enter into the if condition. Else condition, sorry, it doesn't enter into the else condition. Say for example, 15, which makes this condition false. Now let's see. So it says not eligible for vote. Meaning what happened here? 15 greater than or equal to 18, this condition has been verified. This is false. So if it is false, it should not execute the statements under the if condition. So it didn't enter into this loop itself. It just came out of the loop and it knows there's an else statement. It knows if this condition is false, what has to be done. It has to enter into the else loop and execute this statement. So it executed these statements which are under the else loop. So that is the reason we see this output. So this is how if else condition works. So let us understand with one more example. So how do we find if a number is a even number or odd number? So given a number, how do you find if it is an even number or odd number? So say for example, I have some value, like say for example, I have some 13, right? So is it an even number or odd number? It's an odd number, clearly, right? But we wanted to write a program and print this number is odd number. And if I give something like 14 or 20, so it has to print it is even. So how do we write a program for this? Is so whatever the number is. So what we'll do is we are gonna write some logic here. So if number is, so any number, if we divided it by 2, if the remainder is 0, then it's an even number. It's an even number. So say for example, I'm gonna divide it by 2, 13, right? Our example is 13. So With 2, I'm going to divide. 2 6s 12, right? So just concentrate on remainder. So what's the remainder here? 1. So if you get 1, we can call the given number as odd. So take another example. 20. 2 divides 20. 2 tens is 20, right? What's the remainder? We didn't get any remainder. It is 0. So if a number, so if a remainder is 0 when divided by 2, then it's an even number. So this logic we are gonna use. So take any number. If you divide it by 2, if the remainder is 1, we can say it is odd number. If it leaves remainder as 0, then we should call that number as even number. So this is the logic we are going to use now. Let me create a new class. I will call this class as even or odd number. So I'll call this, say, for example, I have some number called 13. Now I'm gonna write a condition. What my condition is? So if number, so do you remember how do we get the remainder? So we have seen this in the last session. Hint is arithmetic operators. So we need to use one arithmetic operator in order to divide the number by 2 to get the remainder. So do anyone remember this? What operator we have to use to get the remainder when divided by 2? We are going to divide this number by 2 and we wanted to get a remainder. So it is modular. Modular. So when we divide this number by 2, we should not use this one. You will get only quotient. So we should be using modulus operator. Modulus operator returns remainder. This we are going to verify now. So say for example, if it is 0, meaning I'm dividing my number by 2. If you see, I'm dividing it using modulus operator because I wanted to have the remainder. I wanted to check the remainder. So if this is going to return 0, that is what I'm comparing here. So also you should be recollecting this operator. This is used, double equals to is used to check the equality of two numbers, right? So if you see here, we divided number by 2 and we use the modulus operator. So we are gonna get the remainder here, 13 percentile 2. So 13 percentile 2 is, we have seen it. So we are gonna get the remainder as 1. So we are going to check that number with 0. We are going to compare that number with 0. Then we'll call that as even number. So we can just say the given number is even. Else, we know if it is not even, we know it is definitely odd, right? We can just write that condition in the else part. So only upon this condition is met, we'll say that the given number is even, or we know if the number is not even. So do we need to write the condition again? We need to check anything? No, because we have only two options. Number can either be even or number can be odd, right? So we are writing it in the else part. So if the number, if it is, we are dividing the number by 2, we are getting the remainder and we are verifying it with 0. If it is 0, then this block of code will be executed and it will say that a given number is even. It will not enter into the else loop again. It will just come out, it will just come here after whatever you have after the else part, and it will see if there are any more statements to execute. As in our case, there are no more statements. It has to come out of the exit the program, right? If this condition is not met, say for example, if it is even, right? So in that case, it will enter into the if condition and it will print the given number is even. So let's check the output. So the given number is odd. So the given number is odd because 13 is an odd number, we know. So when 13 was divided by 2, it yields the remainder as 1. And when it is compared with 0, then that condition has become false. So as this condition is false, it will not enter into this loop. It will enter into the else part. So it will not check the condition again. It will just keep this block of code under if and it will go to the else part as this condition is false. So it just goes to the else part and executes these statements which are part of else block. So the given number is odd. Now, if I'm gonna have this as some 20. So the given number is even. 20 is an even number. So it actually evaluates this expression which is in the if condition. So it evaluates to true because 20% till 2, so is 0. When we divide 20 by 2, the remainder is 0. So 0 is equal to 0. This is used to compare the two numbers, equality of two numbers. So 0 is equal to 0 has become the condition true. So as this condition is true, so it executed this given number is even. It entered into this loop and then executed this statement. And it will not go into the else part of the if condition is met. So simple, if condition is met, the statements under if are executed. If it is not, say for example, if the condition is false, then the statements within else block are executed. So it's as simple as such. Clear? Is it clear? You can put your response on the chat. All right. Now, let's jump on to the next topic. We are done with the if-else part as well. Now, we are going to understand if-else-if ladder. So, what if-else-if ladder is? It is almost the same as if-else. So, if you see here, how do we used to have if condition? So, we used to have if-else like this, right? If condition, if it is met, like if it is true, then we will execute the block of code. If it is not, meaning if the condition is false, we are going to execute else part. Now, within this, we have something called if-else-if ladder. If-else-if ladder, meaning if condition 1. So, if we have multiple conditions, so in that case, what we can do is, we will verify some other condition. So, if my condition 1 is satisfied, like if condition 1 is true, then like if this is evaluated to true, I'll execute this block of statements. Else if meaning, so this condition has become false. This is not met. Then else if will be executed. The following the whatever the statements which are below the if or following if condition, those will be verified. Those will be verified, and then the condition will be checked again. So this is a different condition. So this is a different condition. This we are going to verify else if condition. So this will be verified. If this condition is true, then we will execute another block of code. Let me call this as statements. Statements executed on meeting condition 1 criteria. Condition 2 criteria. So in the same way, I can have another condition defined. This will be my condition 3. So if this condition is true, then these statements are executed. Condition 3 is true, then the statements are executed on this condition. So if this condition is true, these statements are executed. Like this, I can have n number of else if conditions. And finally, we need to have the else condition as well. So say for example, I might be checking for some conditions. What if I don't have if nothing matches? Say in some cases, none of the above is met. So we'll see some examples on that. So say for example, condition 1 is not met. It will come to else if. And remember, if condition 1 is met, so it will not execute the subsequent statement. It will directly jump on to the else part. After the else, whatever we have, so it will come here and execute the statements. But if the condition 1 is not met, so the control flow, so execution flow will come here. So then it will verify this else if part. Else if condition 2, this will be verified. And if it is true, fine. It enters into this loop and it will execute the statements. Done. It comes out of the loop. It even comes out of this part. It will come here and execute the statement. If it is not met, only then it will go and verify the else if, another else if condition, if this is true. Like this, it goes on tries to see the next condition, subsequent condition, wherever the condition is met, till the condition is met. If none of these conditions met are meeting, then else part will be executed. We will have some statements here written. Statements executed. If no condition is met. So this is what if else if latter is. So if and so earlier we used to have if else, right? If there is some condition met, we will execute some statements. If it is not met, we used to execute the else part, else loop, right? Now it is more like if you have multiple conditions to verify, then we use else if ladder using else if keyword. If condition is met, these statements. Else if will verify the condition, these statements will be executed like this. So you have to remember at any point of time, only upon the condition is met, the statements are executed and it will come off this complete if else if ladder. It is not going to verify the subsequent conditions. So let's understand with an example. Say for example, I wanted to verify if a number is a positive number or negative number. So how do we do that? If a number is positive or negative, how do we verify? So if the number, if it is greater than 0, we call it as positive. If the number is less than 0, then we call that number as negative number. But what if it is equal to 0, right? It could be even equal to 0, right? So 0 is neither positive nor negative. Even that condition has to be validated, right? The number can be anything. It could be greater than 0. In that case, we'll say positive. If it is less than 0, in that case, we'll say negative. But if it is 0, we just need to say number is 0. Let me create a new class. I'll call this class as, positive or negative number. And let's say my number is some number, 10. Okay. Now I'm gonna write a condition. We are gonna write a condition. See, if number is greater than 0. If number is greater than 0, what this number is? The number is, the given number is positive. We can write else condition also. So if I say else, it is the given number is negative. Okay, till here let's execute. So it says the given number is positive. Fine, right? So say for example, minus 10 or minus 1, anything, right? It's clearly less than 0. So it has to, it will not, this condition will not be true. So earlier it was 10. So this condition will be met. 10 greater than 0 is true. So it just prints the given number is positive. Now, this condition will not be met. Number is not no more greater than 0. So it has to enter into the else loop and it has to print the given number is negative. And it does. The given number is negative, right? This is fine. Say for example, I have number 0. Number is exactly equal to 0. It still prints negative because we are saying that if this condition is not true, if the given number is not positive, then print it as negative is what we are saying. But there is a special condition for 0. So the number could be 0 even, which is neither positive nor negative. So how do we handle in this case is, so we have to handle even that case. It should not print the given number is negative. 0 is not negative, right? So it should not print that way. So it's incorrect, right? So how do we correct this? We are gonna write a else if condition. Why you are writing this? We have another condition. So we have one more condition. What that condition is? You can't say the number is negative all the time if it is not positive, but verify if the number is less than 0. Verify also if the number is less than 0. Only then call the number is negative. Do not say all the time if the number is not greater than 0. Just don't say that the number is negative. So verify this condition as well. Else if verify this condition if number is less than 0, only then call that number as negative. Now you can say all the conditions are done. Like we verified all the possibilities. So number is greater than 0, number is less than 0 is verified. So there is no other condition or no other possibility except the number has to be 0. Right? Or you can just call it as like that. The given number is 0. Let us execute the program and you can see the correct output now. The given number is 0. So what happened here? So number is equal to 0. The first condition has been verified. G is 0 greater than 0 has been verified. Is that true? No, it is false. If it is false, it is not going to execute the block of statements underneath it. It will verify the next condition. So what is the next condition? We have written the next condition using else if condition. So else if this condition is true or not. Number less than 0, 0 less than 0, this is also false. So it will not execute the statements which are underneath it. So we don't have any other conditions. So we are just seeing the default part, else part. If these two conditions are not met, so directly go and execute this else statement. So what is the else statement? The number is 0. The only possibility we are left with is number only could be 0. That is what we are displaying, right? You can even verify it with, any other values if you want. Minus 100. This is a negative number. So it just says negative number. It all depends on the sign. So if it is negative number, so we add minus, right? So if I just remove that symbol, it will be positive. You can verify for any other numbers as well. Even for even or odd, you can verify for other numbers also and check the output, right? So this is all about if else if. So this is a good example, I think, on if else if ladder. So not only this, if you have multiple conditions, number of multiple conditions to verify, then this else if ladder is very useful. We can add more conditions to verify and to actually verify this conditions are met or not. And finally, we will have a else loop where if nothing is met, we wanted to print something. At least we have to print that none of them met, right? So for that, we can have the else loop. Again, like whatever statements are there after this loop, so those will be executed. So if condition is met, then this block of code will be executed and none of this will be verified. It directly comes to this and executes the statements which are out of this if else if ladder. Same goes for any other condition as well. Say for example, if condition is false, then we are going to verify else if. Else if will be verified, and if it is true, fine. Then it will just execute only this part, the highlighted part, and it will just come out of this complete if else if ladder. It is not going to go to the subsequent conditions to verify, as the condition is already met. So this is all about if else if ladder. An example on else if else if ladder. Now let's take another example to understand it better. I wanted to find largest of three numbers. So I do have three numbers. We wanted to find largest of three numbers. How do we do that? We wanted to find, say for example, I have some three numbers. Which number is highest? We know clearly C is highest, right? But how do you write it programmatically? How do you find it programmatically? Writing a program, you have to find which number is largest number. So how can we do? We write the logic is, if you can recollect, we did discuss about the comparison operators or relational operators in the last session. So that we are gonna use it now. So I'll be writing a if condition. We'll say if A is greater than B, right? So let's actually write the logic. Let's create the program and write the logic. But before that, what's the logic? I'll explain you. So if A is greater than B, and also A has to be, if A is greater than B, then we'll verify if A is greater than C also. Then we'll say, we can say A is largest, right? So two conditions. So if you take A, if you wanted to find if A is largest, we'll compare A with B. If it is true, meaning if A is greater than B, then we'll verify it with C as well. If A is greater than C as well, then A is the largest number. Say if A is not greater than B, then we clearly know that either B or C will be the largest. Then we can verify the condition if B is greater than C. If B is greater than C, then it says that it means that B is the largest number, or else C is the largest number. Okay, let's see that programmatically. So let me create a new class. I'll call my class name as largest number. Largest of, we'll say three numbers. Is this a valid syntax? Or sorry, valid convention for the class name? I'm using the number in between class name. So this is a valid convention for the class name. We can use numbers in between the class name. It should not start with number, but we can use the number in the class name. So in number equal to, sorry, we need to have three numbers now. So we do have three numbers. We wanted to find the largest number among these numbers. So what do you mean by y? What was the question? Yeah, all right. Be clear on your chat messages. So I thought that is y. Oh, I was thinking it is question. Okay, all right. So we have three numbers now. We wanted to find which is the largest number. Now, what we can do for this is, so we'll first check a condition. If A greater than B. If A is greater than B, then what else we need to check? So we know B is definitely B can't be the largest number. So either A or C can be the largest number. So that's a possibility we are in now, right? So we can check another condition. If A is greater than C is what we can check. If A is greater than C as well, then we can say definitely A is largest. But you know that A is greater than B. So you entered into a loop and we are verifying if A is greater than C. So definitely B can't be the largest number as A is greater than B. So we are into that loop. So either A or C can be the largest. And also we are verifying inside this loop, there are two possibilities. Either A or C can be the largest one. And to check that, we are verifying this condition if A is greater than C. So A is largest. If A is greater than C, then definitely A is largest. But if A is, if this condition is false, so definitely C will be the largest. Try to understand this logic. So if A is greater than B, so we are entering into a loop. So there is a possibility that we know that B is less than A, right? B can't be the largest number. So now either A or C can be the largest number. So inside that loop, we are verifying if A is greater than C. Another condition. So if it is so, if A is largest, or else C could be the largest number. So this is one case. And now, what if A is less than B? Meaning B or C can be the possibilities for the largest numbers. So what does this else means is A is less than B. So if A is less than B, then either B or C could be the largest numbers. That we are going to verify now. If B is greater than C, if it is so, then B is largest. Else, C is largest. So what did we write here? If A is less than B, meaning B is greater than A, right? So we know B is greater than A. In this case, so it will come into the else part. Now we have to verify if either B or C is the largest number. Again, we are writing a condition if B is greater than C, then we'll write it as B is largest, or else we'll say C is the largest number. Yeah, we'll see that later. First, so let's see with this. So C is largest, right? So it prints C is largest because clearly we can see 10, 20, 30. C is largest, right? It verifies with this condition 10 greater than 30 false. Then it will come to the else part as this condition has failed. So now what happens? It will be verified with B. So even 20 greater than 30, even this has become false. Now it entered into this else part and then it just prints C is largest, right? Now let me verify. Let's see all the possibilities. Now it says B is largest. You can clearly see this, right? So depending upon this condition, so it will actually verify this condition 10 greater than 40 will be false. So this condition else part will be verified. So 40 greater than 30, this will be true. B is largest. Fine. Now, for example, A is 50 and A is largest. So it means A is largest. So the program is fine. It's working perfectly for all the numbers, right? So, but if you observe, this we call it as nested if else, nested if. So what is nested if is, nested if condition is, so you'll have if condition within if condition. So this is what we call it as nested if else. So if you observe, we had a if condition and again we are having another if condition within the if condition. If this condition is met, we are again having another condition to verify with after that condition is met. So like this, we can have n number of conditions within if I can have if again within that if I can have another if condition. Like that, I can have n number of conditions nested. So as these are within one if, there is another if, like this, there is a nest. So we call this as nested if else. But if you see, the code is not readable and the code is also growing. And also if you observe, C is largest, so there is a redundant code here, right? So in order to avoid this, instead of writing like this, if you observe, so we are checking one condition and we are immediately after checking that condition, if it is true, we are checking another condition. Instead of this, what we can do is, we understood logical operators in the last session. So we can use those logical operators and write the condition in one statement. In one expression, we can do this. So let me show you how to do that. We're gonna use the logical operators. If A is greater than B, we are gonna use a logical AND operator. If A is greater than C as well, then we can say, we can have the curly brace like this also. It need not, we don't need to bring it down. So just for readability and just for, matching. So we are getting it here, or else you can even have it like this. By default, it will be like this. If you try to create the if condition, see, if I say if A greater than B, and if I open curly braces here and just hit enter, it knows it has to have the its paid close brace. So it is giving this brace here. So it's up to us. So if we see this condition, so you have to recollect this logical operator. What this logical AND does, so it evaluates to true only if the two Boolean values are. So first of all, logical operator can be applied only on Boolean values. We know that, right? So if you see, we have two Boolean values here, A greater than B. A greater than B, we should result either true or false. A greater than C also should return a Boolean value. So we are applying logical operator between two Boolean values now. And again, the result will be a Boolean value. Based on that, we are taking some action, right? So A greater than B and A greater than C. We are verifying both the conditions. So logical AND is true only if both the conditions are true. So if A is greater than B and A is greater than C is what we are verifying. If both are true, meaning A is largest. Else if. When we come to else if one of these conditions is false. When will this one of these condition will be false? If A is not greater than one of B or C, right? So we are just verifying if A is the largest with this condition. Now we'll verify if B is the largest number. So how do you do that? If B is greater than A, straightforward. If B is greater than C, if we are verifying if B is greater than A and also if B is greater than C. Again, this will be true only if both the conditions are true. Both the conditions will be true if B is the largest number. If B is greater than A and B is greater than C, both will become true. If both becomes true, then we'll say that B is largest number. So do we need to check other condition? So we verified if A is greater than B and C, then we can say is largest. Else if another condition, if B is greater than A and if B is greater than C, then we can say B is largest. So if this condition fails, then we definitely know A is not the largest. If this condition also fails, then we know that B is also not largest. So there is no other possibility. There are only three numbers. So we don't need to write any other condition. So in such cases, we use the else part. We will definitely know C will be the largest. And you can clearly verify the output. C is largest here, right? Let's verify another condition, making B as largest. So you can see B is largest. So the first condition, it will become false. At what place? This place. 10 greater than 40, it will be false, right? And as it is false, logical and it will not even go to the second condition. So as this is false, anyway, even if this is true or false, irrespective of that result, the whole expression will be false. So it will not even verify the other conditions. It will just goes to the next condition, verifies the next condition, else if. So B is greater than A, 40 is greater than 10, 40 is greater than 30 as well. So this statement will be executed and it will just come out of the if else if ladder. We'll verify other condition. Yes, A is largest. You can clearly see that. So definitely, instead of using nested if, this was nested if condition within if. So if else condition within if, right? So we call this as nested if else. But instead of that, we can use if else if ladder only. So when we wanted to have the multiple conditions, multiple choices to be validated or verified, then it's better we use if else if. The code is readable also, and it will be very quick as we are using logical operators, logical and here, especially logical operator, logical and, right? All right, now hope this is clear. Is this clear? If it is clear, we can jump on to the next topic. All right, now let's jump on to the next topic. If it is not clear, I'm gonna explain you one more if else, or else I'll give you that as an assignment. Okay, so you can take, yeah, I'll be going to give you anyway assignments. You're gonna practice that assignments, then you'll clearly understand it. Now, so we did understand if else if as if else if also, right? Now let's go back. Switch case. Now we are left with switch case. So switch case, how it works is it selects one of many blocks of code to be executed. So to look at it, it looks like same as if else if ladder. So what if else if ladder used to do, it executes one block of code out of multiple conditions. If else if, it used to execute one block of code out of multiple conditions. So switch is also almost the same. So if else, it executes one block of code if a specified condition is true, and another block of code if it is false. What? How if used to work? So just to recap, so it executes a block of code if a specified condition is true. If else, it executes one block of code only if a specified condition is true, and another block of code if it is false. Now we understood, like we also understood if else if ladder executes one block of code out of multiple choices, right? Multiple conditions. Now switch case. Switch case selects one of many blocks of code to be executed. Yeah. So let me show you the syntax. Switch some expression here. And then so we evaluate cases here. So we'll actually compare this expression, whatever expression we have here. So we'll compare it with, cases here. Say for example, case some expression again. Then a statement to be executed. This expression is compared with this case. Equality. If it is same, if it is equals, then it executes the statement. Like this, we can have n number of cases. And we do have a default case where we execute the statements. Default, these are the default statements. This is the syntax of switch. So let us take an example of week of a day. So what we wanted to do is, if I give, this is an integer, day is an integer variable. If I give it as 1, so it has to print me, it is Sunday. So if I give it as 2, it has to print me, the day is Monday. If it is 7, it has to print Saturday. So this is the program we are going to write now. First, let us write this program using else if ladder. As we have multiple options, right? So we'll write it using if else if ladder. Week name, if else if. How do we write if else if? We know, right? If day is equal to 1. So equality, so we use the double equals to symbol. If day equal to 1, then we call this a Sunday. What if it doesn't match us with that? So we have wanted to have another condition. We wanted to verify if day is 2. Day is equal to 2. If day is 2, then we wanted to display it as Monday. In the same way, we have other multiple options, right? So day could be 3, in which case we are going to print it as Tuesday. It could be 4, then it is Wednesday. If it is 5, it will be Thursday. Friday, and then we don't need to write the condition for this, right? So if it is not going to be any of these 6 days, then it will definitely be Saturday. So what did we do here? In order to find the week name depending on the day. So if it is first day of the week, then we know it is a Sunday. So it has to display Sunday. If it is 2, it has to display Monday, and so on. If it is 7 or if it is 6, it has to display Friday. If it is 7, it has to display Saturday. Right? So let's run this. So you can see it displays Sunday. Now let me show you. Let's take 2. It displays as Monday. Fine. Say for example, if it is 6. What is 6th day of the week? It is Friday. Yeah, it displays Friday. Fine. If I have 7, it should display Saturday. Yes, fine. But what if I give some invalid day? There are only 7 days per the week, but I'm going to give some invalid day. So it still displays Saturday, which is incorrect, right? So how do you fix it again? So we should not put it in the else part. We again need to check this condition as well. If day is 7, only then display it as Saturday. Else part, there is no other choice. So if you are coming here to this condition, meaning you are not providing a value between 1 and 7. So that is what we are going to display. You are providing some incorrect day number is what we'll say. Now if you verify, as the day has been provided as 10, it will say incorrect day number. If you give some other valid input day, then it will say Thursday, right? So this is how we can find the week name depending like using the else if ladder, right? Now, if you see this code, so the code is like, you can see there are multiple choices, and that's fine. We are verifying it each condition, right? So the same condition, the same program can be written using switch case statement as well. So how do we do that? Let's verify it now. We call this a switch case statement. So how are we going to do that? Which whatever we wanted to evaluate for equality, that we are going to write it here as an expression, and here we'll compare it. The cases in the sense, what's the value you wanted to compare it with? I wanted to compare it with 1. If day is equals to 1, so this expression whatever we are enclosed in switch statement, that will be compared with whatever cases we are writing here. So if it is 1, it displays Sunday and break. I'll come to this break in a minute. So just just think of it like we need to have this break statement written after each statement. So like this, we could have 5, 6, 7, right? So if it is 7, 2 again. Okay. Wednesday, Thursday, Friday, and Saturday, right? Now, if it is not going to be any of these numbers, 1, 2, 3, 4, 5, 6, 7, 7 days in a week. So nothing matches, then we will display it as invalid or incorrect day, incorrect week number, right? So this is how we write the switch statement. So it is very easy also, right? It is also clear, readable than if else if ladder, right? So for this case at least. Now let us execute this and understand it. So it says Sunday because what happened here? Let's understand that. So day equal to 1. So switch statement, what it does, it takes some expression here. So it took one expression, that is day here. So it is comparing it with the cases. So what are the cases? So if you observe clearly, case is a keyword. So you should be observing this. You need to observe these colors in this editor, right? Whatever are there in this color, those are keywords. So day is compared with this case values. Case 1. If day is equal to 1 is what is compared. If it is so, just print Sunday and then break. What break is? Break is a jumping statement which we will discuss in the next session. But for now, just think of it like we need to write this break to break the execution of the program here. Execution of the program in the sense execution of the switch statement, right? The switch statement completes execution once it is break statement, right? So it prints Sunday and then break. So it just comes out of the switch statement. Or else, if it is not matches with day 1, then it goes and verifies with case 2. If it is the case, then it prints this Monday and then break. It will come out of the switch statement and so on. And why do we have default is, say for example, the case number, day number is doesn't matches with any of these 1 to 7. Then in that case, we should have some default value. That is what it is. So though default is optional, so we can use the default value because if the input is doesn't matches with the expected input, then we can use the default statement and provide some valid message there. So 1 is executed, right? So let's verify for 3. So 3 is Tuesday. Yeah, perfectly fine, right? Now let's execute 7. 7 is Saturday. So it prints Saturday. Fine. Now I'll just add 117. It has to say invalid week number. So switch statement is working fine. Now, why do we need to use break statement, right? Break is used to break the break the switch statement then and there, and it is coming out of the switch statement, right? So say for example, if I don't have the break statement, it's a fall through. Fall through in the sense it will execute this as well as it will execute the subsequent statements as well if you don't have the break statement. For example, I have one. So if you see, as the day is one, it has to print only Sunday, but it prints Monday as well because days compared with first case, it matches. So it prints Sunday and it don't see break statement. So it's a fall through in switch case. So you have to remember this. We call this as fall through. Fall through in the sense, if it doesn't find the break statement, it will go on execute the remaining statements. It will not verify this condition. So this condition is met. So it will display whatever statement here or whatever block of code you are writing under case. So it will execute these statements. And then as you don't see break, it will jump on to the next statement. And it will just execute all the statements below it. It will not even consider this condition. So that we call it as fall through. So in order to avoid that, we actually use the break statement. Say for example, I don't have break statement for the case 2 as well. Then what happens? See, Sunday, it just went on to the next statement Monday. Now it will not verify these conditions. So it will just, it matches with case 1. So it prints Sunday and there is no break. So it falls through and it will display Monday. It will go to Tuesday and then it's a break. So it is breaking. It breaks there and comes out of the switch statement. So if our intention is not to break, then we can actually remove these break statements. But in most of the cases when we are using switch statements, like our intention will be to execute only block of a code upon some condition is met, right? If some condition is met, we wanted to execute only a block of code or some statements, and then we wanted to come out of the switch statement. So if you wanted to have the fall through, meaning if your condition matches with one case and you still wanted to execute subsequent statements, then you don't need to use the break. But if you wanted to stop the execution there, then definitely stop the, verifying the condition, or if you don't want it to go through all the statements, then you definitely need to provide the break statement. So if you observe, there is no break for the default statement because there are no more statements after default, right? So you don't need break. This is the case. This is the reason we don't have break. So anyway, if the day is invalid, if it doesn't fall within the range 1 and 7, it comes to default and there are no subsequent statements to execute. So even though you write break or not, it makes no difference. It will execute only the statement and comes out of the switch statement. Now, so is that clear? This is how you need to use a switch case. Is this clear? All right. Now, let us understand the differences. So you might get that question, right? So weak name, both are same. Like we actually understood weak name with the if else if ladder, and same with the switch statement as well. We are getting the output same. So what's the difference? So we'll understand this difference now. So switch is faster, definitely faster, because it uses, because it when we use switch is faster as it uses jump table in bytecode. So if you remember, if we compile the Java code, so we get a dot class file which has the bytecode. So this is done by, so when we actually compile the code, so the dot class any class file, so whatever class files we are creating here, if you observe, it has the extension .java, right? So once we compile the code, what we mean by compiling the code is, so once we write the code, So there should not be any syntax errors in it. Syntax error. Say for example, I say uppercase S here. So it says we are getting many errors. It says syntax error on tokens, right? So you should not get such errors. You should not see such errors in your program. So it should be, syntax error free. Then, or you should not have any errors in your program. Only then we can compile your code. So upon compiling the code, so if there are no errors in your code, so then that gets compiled, right? If there are errors, it compiles and it throws the errors like how we did just now, right? So if there are no errors, the code gets compiled successfully and a dot class file gets generated for each class, for each Java class file. And then that class file will be having the bytecode. So this we discussed in the first session. So it will have the bytecode. So this bytecode, within this bytecode, how switch works is, so the logic is, it will have a jump table. The instructions will be translated into some other way where we will be having some jump table. So whatever number you have it here, say for example, you have 5. So it doesn't verify this all the conditions. It will directly jump onto the case 5 and execute this statement. So we can say switch statement is faster in performance, right? Now let us understand the differences. So if else if and switch. So here the condition is expression evaluated to Boolean. If you observe any if or else if condition, so it was evaluated to Boolean value, either true or false. Only upon that we actually execute the subsequent statements, right? So in switch, so if you go back to the switch, so this could be integer, this could be short, byte, it could be even char, it could be even string. So this, whatever we are having in the switch statement, this expression can be byte, short, char, int, or string data types. Not only int, right? So we have seen an example on int, but it could be any of these 5 data types. It could even be enum as well. We'll discuss in the coming sessions what enum is also. Okay. And yeah, what is the next difference is, so if else if, so it allows complex conditions and expressions. So it allows if you have complex conditions, like say for example, we have seen to find the largest of 3 numbers, we have used some logical operators. Like that, we can have some complex condition as well. So in such cases, we can use if else if. So, but in switch case, you can't use it. So you can't use complex logic. So because if you observe, this is only used for the equality, to check the equality. So in this case, all the cases, we are checking only equality. If this expression is equal to this case, is what we are verifying. So if our purpose is only equality, then we can use the switch statement, because each case value must be only constant or literal. There you can't write the complex condition or the expression. So if you have a complex condition and expression, so if else if can be used, right? So that's the difference. So these are the actual differences, and when to use what is also comes under that. So like when do we use if else if? So looking upon this, we can clearly say that when conditions involve complex expressions or logical operations, or if you have a range of values, say for example, if you wanted to compare range of values, if it is greater than 90, right? But less than 100, if it is greater than 80, but less than 90, like that, if you have multiple conditions, which involves complex expressions, then or also if you wanted to compare the range of values, or if you wanted to compare if you have multiple variables to be used in the if condition, then we can use the if else if ladder. And when to use the switch statement? So we can use the switch statement when the condition is straightforward and involves the single variable equality checks. So if you have the single variable equality checks against a set of discrete values. Discrete values are individual and separate values. So if you wanted to check the equality of the separate values, then we can use the switch statement. Or else we should go for if else if ladder. So If you understand correctly, if else if and switch statements we are using when we wanted to have the multiple choice, when we have the multiple choices to be verified, right? So anyone can be used depending upon the purpose. So if it involves complex expressions and range of values to be compared, then it can't be done with the switch statement. So you should definitely go for the if else if ladder. But if it is straightforward and if it is only equality check, then which is the best case, like yeah, best statement so to use. So this is all about control statements. Hope this is clear. Today's session is clear. So if it is clear, I'm gonna give you some assignments for today. If you have any questions, you can ask. Or else, so you can see this assignment. So you need to find the largest of two numbers. So we have seen largest of three numbers. So the hint is you can use if else or you can use ternary operator as well. In the last session, we have seen what ternary operator is, right? Ternary operator, right? So largest of two numbers, you need to find it out. Given two numbers, you have to say which number is the largest. And you have to find which number is smallest. Like given three small numbers, so sorry, given three numbers, you have to say which number is small. We have seen the largest of three numbers. You have to find the smallest of the three numbers. So you can use if else or you can use if else if ladder. And we wanted to print the week number based on the week name. So we have seen the reverse of it. So when I provide the day, so when we provide the day number, we used to print what week name of that day, right? 7, it is Saturday. 1, it is Sunday, like that, right? So if you provide the number, we actually have seen the week name of it. So this assignment is exactly the reverse of it. So it is something like we provide the week number, print week number. We provide the string week name is equal to, I'm going to provide it something like this. Based on this, you will write a switch statement, something like this. And you will write the case statements like this. If it is Sunday, then you will just print 1. If it is Monday, you will display it as 2. And so on. Right? So default, you will have it as if week name is some invalid, if it is some invalid name, right? So say, for example, I give it as something like this. So January is not a week name, right? So you should just say invalid week name. So try this assignment, and if you are not able to achieve it, we will see it in the next session. So all these are the assignments you have to work on. And then, yeah, also go through the today's session recording. So I'll stop here.